Hello, and welcome back to the UglyCode live stream. It is January 7th, so Happy New Year. This is the first stream of 2025 for us. Yeah. So I've just been experimenting with a few things in OBS, so I've got a few things to try out. I also wanted to try designing something for the 3D printer today, and maybe we'll play around with the Wacom tablet. Maybe. Yeah, let's get into it. So, which one do I want? This one. There we go. This one here. Okay, so my measurements I saved over here, and I'll just copy them in. Okay, so those are the measurements from the stream the other day where I measured the candle, the LED tea light candle, with the calipers to get the measurements for it. Just make sure that it's on the right screen here. Yeah, OBS shows it is, and it can hear me. It looks like YouTube's a little bit behind, but that's okay. Okay. So, one of the first things that I usually like to start off with whenever I'm starting a new OpenSCAD project is some of my very basic definitions, like my tolerances. So I like that to be 0.1. Layer height should be 0.2, and wall thickness 0.4. Those are you can change those in your settings, but that's usually the default, so that's what I'm designing for in this case. I think there is an echo. Here, one sec. Let me move the microphone in front of me. Is that better? Maybe? Okay. Well, I'll listen to it later and see if that actually resolved it or not. It might also be the second mic, but I don't think... Here, one second. Let me just check the audio settings, because I don't think it's enabled. Right click here. There we go. Yeah, no, it's just a snowball. And the music. That's the other thing I wanted to check is if I'm just casually talking over the music, is it quiet enough and in the background enough, or is it too distracting? I think this song, along with something quiet like coding, should help to kind of just fill the silences. So let's see how this goes. Okay, so let's start off with the cylinder, and we want height, radius 1 and radius 2. Those can be the same, or if we want to make some kind of cones, which we will later on, then we can change the different values there. So that's the radius at the bottom and radius at the top of the cone. And then there is also an optional parameter of whether or not we wanted to center it, which, yeah, I think we do. Okay, so let's start off with... This is a radius, so we want to cut that in half for now. There we go. Oh, the other parameter that I like to add to this usually is $FN. So that's the facet number. So by default, I forget what the default is right now. But here, if I put in, for example, equals 96, we'll get a much smoother cylinder. There we go. So it's adding in more facets into the circle that makes up the cylinder. And we can also crank that way up. So when I'm when I'm doing some when I'm getting something ready to go to the printer, sometimes I'll just crank this all the way up to 360 degrees, and then I get a really, really smooth circle, or cylinder, I guess. But the drawback of that is if you do that too much, it makes your renders really, really, really slow. So it can take, if I push it and do that a lot, it can take upwards of like an hour to finish rendering my STL file. So for now, let's set that to something more reasonable, like 96. The other thing I like to do is define that up here as fn equals 96. And then I just say fn, $fn equals fn anytime I want to apply that to an object. And then I only have to change it in one place later on. And we can also set that number really low too, so you can have you can make some shapes with it. If you set it to stuff like 5 gives you a pentagon, 4 gives you a square, 3 gives you a triangle, and below that I don't think it'll actually do anything. Yeah, that would just probably throw an error in the console. So as long as you're giving it enough facets for a polygon, it'll give you a shape, and as long as you give it a reasonable number of facets, it'll give you something that resembles a cylinder. Anyway, let's go back to 96 and leave it at that for now. Okay, so I use the outer width. Actually, let's start by modeling the candle itself, and then... Okay, so here, we've got our cylinder here, and that's using the inner height. Okay, so let's change that to the outer height. Okay, so it's a little bit taller now, and that's what the candle, the shape of the candle that I'm using looks like. And then let's make it hollow with a difference operation. And so difference will take the first object that it's passed and subtract the subsequent objects from it. So in this case, I want to start with the biggest cylinder representing the outer walls of the LED candle, and then we'll pass it the inner cylinder that we want to subtract. And we will also have to translate that a little bit. I'll just put in the operation now, but first we'll just set it to 0, 0, 0. That currently does nothing, but it's there for when I want to change this. Okay, so that's the inner height, and we want the inner width divided by 2. Okay, now we're not going to see anything yet because right now it's centering it inside of the other cylinder. So because all of these dimensions are smaller than these dimensions, it is hollow, but we can't see it. So now let's try increasing the Z translation. Let's just throw in a number like 10 just to get it up, and so we'll see a hole, and then we'll fine tune it a bit. There we go. Okay, now what was the difference between the inner and outer? It's like 14.9. Okay, so let's... That should be inside of it. Okay, and then... Okay. Okay, so that should be roughly the shape of the candle, except I did approximate the 50, so that was just kind of looking to where the looking through the side of it where the bottom of the candle seemed to be. It was kind of hard, like I couldn't actually get the calipers in there. So, I mean, realistically, this should actually probably be a little bit deeper. So let's add on. Let's just say 4. -2. There we go. Yeah. Perfect. Okay. And this, we will change the color to, let's make the candle. What color is that? A little bit too bright. Make the candle a little bit more greenish. Oh, it might want values between 0 and 1, I think. So let's do 0.5, 0.75. There we go. Okay, let's brighten that up a little bit more so it looks a little bit more like the candle that I actually have here. Let's do that will be the stand-in for our candle. We can comment it out later or make it conditional so that it doesn't actually get rendered in. And then this will be what we will design the tree to go. Currently I'm thinking I'll make it as an insert, and then we'll make a version later on that goes over it. Yeah. So let's start off with inner height and hollow that out in a second, but first I want to get it rendering, and I also want to get it rendering in the color that I'll be printing it, so it looks roughly like it'll turn out. So let's set this to 0, 1, 0. Okay, that's, oh, should be inner width divided by 2. I also want to translate this down a little bit. Yeah, because I want to keep this, the rest of this centered. We'll move the candle down to compensate for that. think if we offset it by the difference of those, it should be what I wanted. There we go. Okay. So the base piece of the tree will be the center from which we build everything. The candle is just kind of offset down a little bit. And let's hollow this out. So I really only want it to be a single wall thick because I want it to let as much light through as possible. So it's going to insert into the candle, mainly just for stability. And then from the top of the candle, it will just kind of grow outward at a 45-degree angle, because the way that 3D printing works, every layer is printed on the layer beneath it. And so if you want to try and grow outward, I mean, some printers can do a little bit more than 45 degrees. That's not the absolute limit, but I find that 45 is a good angle to design for. At least for supportless design. So, wow, I really have to lean close to this microphone. If I'm too far away, it doesn't even hear me. I wonder if I should get some kind of microphone arm at some point so that it can just hold the microphone near my face. Well, maybe we'll design that and 3D print it, or maybe there's something on Thingiverse. I'll have to take a look later. But we'll save that for afterward. Okay, so we've got our green cylinder, and we want it to be hollow. So we start off with a difference function. And our curly braces, and then inside of the curly braces we pass it the cylinder that we are using as our base, and then the cylinder that we are subtracting from it. And for this one, we'll just take the radius, and we'll I think if we just subtract just one wall. Yes, because we want it to be one wall the whole way around. So let's just do minus W. And so the other thing, as soon as I save this, you'll see kind of a little bit of weirdness on the top here. So I'll zoom in so you can see it. When I save, you'll notice this weird pattern that's kind of like a crosshatch or like a grid pattern. That basically that's because the two cylinders are exactly the same height. And so there's just the way that OpenSCAD renders it, there's like this infinitesimal thin layer that doesn't actually exist, but it's kind of left over there. So what I usually like to do to deal with that is I will just add on the smallest amount that the smallest unit that I have saved. So plus T, that will make it 1/10 of a millimeter taller. And then yes, and then we want to offset it vertically by half a tolerance. So the bottom is, wait, no, I want it to difference both ends, so I actually don't have to do this at all. I just need it to be slightly taller, and I don't have to offset it at all because they're both going to be centered. This one is just going to poke out half a tolerance above and below, but we're not even going to see that because this is what is subtracted from the other piece. What we will see is that this infinitesimal non-existent layer will disappear. There we go. Now we have a nice hollow cylinder fitting inside of our other cylinder. Now this is one of the reasons that I like to generate the model of the thing that I'm designing for, because sometimes this helps me to visualize what the actual measurements that I'm designing for are, and so later on when I actually find out what the depth of the candle is, I can make this more realistic. I can program in the tolerances so that I can actually see a tiny gap around this. Right now, we're just going to try printing this and see how it fits, because the candles themselves are made of wax, and I find with single walls, there's a little bit of give in this anyway, so it might just fit snugly inside. But we'll print the first version, see how that goes, and then maybe add in a tolerance or two, depending on how it fits. Okay, so the next thing that we probably want to do let's add a cylinder above this that flares out at 45 degrees to form the base of our Christmas tree. And how much do we want this to flare out? I hadn't really given much consideration to the dimensions of the Christmas tree yet. Well, actually I had, but I didn't really settle on any actual measurements. So, I don't know, let's just keep it simple for now. We'll do some research later. So we start off with our cylinder. Let's say, a centimeter maybe? And we want this to be the same width as this one. Okay. Now, let's translate that upward, and we want it to go I think it needs to go half of the height of the cylinder that it's trying to move above, so outer H, that's the inner one, plus its own height divided by 2. Wrap that in brackets. Okay, and just to see if I got that right, let's add on so if I add on a tolerance, I see a tiny little sliver through there. And if I take the tolerance off, they line up perfectly. Awesome. Let's also, we'll just copy this line for now, but later on we'll group this all together and apply the color to everything. Right now we're just doing this in layers, like a cake. So the next thing we want to do is difference that to make it hollow. Now it is worth noting the operations at the inside here. When these objects first are created, they are centered, so I don't need to worry about their offset at this point. So right now I can just make this one taller than the other one, and it will always be centered together. And then, so this is the only height that once the difference operation is completed, this is the only height that matters, because this object is essentially negative. It disappears. So, oh, and we want to make this smaller too, because if we subtract that, it's going to make it completely hollow, because they're the same radius. So let's do inner width minus a wall. And we wanted this one to grow out at 45 degrees. So we actually probably we should change this one too. So we want it to go from inner width divided by 2 to inner width divided by 2 plus, let's see, we want this, for a 45 degree, we want the rise and run to be 1 to 1. So we want the slope, if we increase the height by 10, we should increase the radius by 10, I think. Let's try that. There we go. Okay, let's just look at it at a 90-degree angle. There. Okay, yeah, we can see that that has a nice 45-degree slope to it. And then the inside doesn't yet, but we'll get to that. So, we've got our first part here where we've taken the wall off, so that should line up with the lower part. And then let's expand the upper radius by 10 minus W. So they'll grow, yes, there should be 2 cones that are nested, and that should work. Sometimes I have to adjust the values just a little bit, just so that it overshoots and undershoots the object that it's subtracting from. So the cylinder will not only, or the differenced cylinder will not only go half a tolerance above and beyond, or sometimes even a full tolerance. It might also have a slightly smaller radius for the bottom radius and a slightly larger radius for the top, just so that so that it overshoots the margins just a tiny bit, while maintaining the same slope. But let's see, that might not be necessary here. Yeah, I think it is. Oh, hang on. No, this one needs to go... No, that's the outer cylinder. So we want that to be... Let's try taking the tolerance off. Actually, yeah, let's overshoot this a tiny bit. So we'll do plus W on the top, minus W on the bottom, and we'll add there, I think. Nope. Okay, so now it's cutting it down to half because they're intersecting, and that's not what we want. Oh, hang on. Okay, so we do want this to be offset by a wall, but we also want to subtract a T. And up here we want it, yes, offset inward by a wall, but we want to add a T. And here we want to add 2 T's. And that maintains the slope. Because we want to subtract a wall from both the top and the bottom to maintain the consistent thickness of the cone. And then this here needs to be subtracted from the bottom and added onto the top to match the slope of the tolerance that we've added here. Now, I don't think this is strictly necessary because I think those infinitesimal layers, I think they actually disappear when you render, but they are a pain in the ass when I'm trying to preview. And so usually I like to design around it by just extending my difference to objects, or yeah, extending my difference objects. Negative objects? I don't know what the proper terminology is for it. Negative space, void space, you get the idea. The anti-cylinder. There we go. Okay, so let's try saving this and see if that improved it, because I think it should. Yes, that's exactly what I wanted right there. So that it meets up perfectly at the edge there. And if we were to difference this with a cube or something to get a cutaway, like a cross section, we would see that this is exactly a wall thick the whole way down, 45-degree surfaces on the top and the bottom, which is exactly what I want. Okay, so now let's add another one. Yeah, we'll keep this small for now, just for a prototype, so that I can print it, put it on the candle, and even see if this lights up very nicely. And then I'll do another one with better measurements after I've had some time to study the proper dimensions of a Christmas tree. I mean, again, I did that already, like I kind of looked it up, but I didn't really write down the notes, and so I figured that would be something that I'd have time to do later. So, here, let's add another cylinder. And so what I'm thinking is we'll build our Christmas tree out at a 45-degree angle to kind of approximate the lower flat branches. And then we'll bring it in at a sharper angle, but for a much higher, a higher travel distance, I guess. So we'll travel in less, or well, I guess over time we'll travel in more. Sorry, I guess what I'm trying to say is it'll have less of an inward slope because it'll be going, like let's say 30 degrees instead of 45 degrees. So it'll travel in less, but it'll be going higher. So ultimately it'll travel in more, and we'll just kind of keep repeating that pattern until we get to the top of the Christmas tree. Sorry, that was a terrible description of the geometry here, but I'm not a geometry teacher. Okay, so let's copy this. We've got our cylinder, and we wanted this to be 20. Actually, wait, if we go out 10. Yeah, let's start off with double the height for now. We can always change that. And we'll translate it. Right, this one needs to be the height of this cylinder. So the height of the base cylinder that we're traveling up, and then the height of this cylinder divided by 2. Okay. And now we want this one to be this width. No, this width here, the thicker one. So I guess the better word is radius, this radius here. Okay, so that'll line up with that and go straight vertical. And then, what did I say? I want this one to go up a centimeter, and so we should probably have this go... Yeah, let's start off with 2 for now. And so any slope that's... So we at least, as long as we don't travel 2 centimeters in, we're going to have a steeper slope than 45 degrees. So, let's see, we're going up 20. There, so that should line, I mean, here, if we look at that, there we go. It lines up with both heights because it only travels out 10 and then it travels in 10. So we probably want that to be... Actually, let's see how it looks when I do 45. Because again, this isn't the final version. So right now, I kind of want to close this off faster, I guess. Yeah, close it off faster so it doesn't waste a huge amount of layers on the first version. Okay, so we got plus 10. There we go. So that's what we get if we make it go 45 out and then 45 in, but twice the distance. So that is not what a Christmas tree looks like, but let's try continuing that pattern and just see. Yeah, because I should be able to close that off in just one more tier. Oh, and we need to difference this. Can you hear me? There we go. Okay. And so we want this one to be offset inward by a wall. Oh, actually, hang on. We'll leave our offset there first. Okay, so now we do the inward by a wall. And which way is our slope going? It's going from bottom to top. It's going in. So we want this to actually thicker at, or wider at the base. And no. Subtract the W, add the T. That's what we want. Because it should still be offset inward by a wall. But then when we're overshooting, we want it wider at the base. And narrower at the top. That should... yeah. There we go. Perfect. Okay, yeah, I think I'll stick with this for now. We'll try the steeper cones later on, but right now I think 45 degrees is good for prototyping. Okay. So now let's do another 10. We want this one to be, no, this radius here. We'll add 10 onto that. translate it up by... Oh, and we'll also add the color. Okay, and... Yeah, we'll just save it and adjust the values from there. Okay, so I think that needs another 20, maybe 30. No, too much. There. That should be perfect. Okay, and then let's get the differencing going here. Plus T. I think that should do it. Yeah, there we go. Perfect. Okay. Now let's close that off with one more 20. There we go. And that needs to be narrower. Let's take this radius. Yeah. Okay, so that was actually kind of what I was talking about by a steeper angle, but again, we'll just close this one off so I can print it. And I think, how long has this stream even been going on for? It feels like it's been probably almost an hour by now. So let's just get it sent off to the printer. This one, yeah, needs to be plus T. Oh, that's right. The radius is not... I've been basing everything off of 10s here, but the radius is actually 35.6. Look at this from the side for a second. So this is 35.6 millimeters across. Divided by 2 though, because it's radius. And then wait, so like 18-ish? Yeah. It's probably 17.5. Yeah, 17.5-ish times 2 for the full width. And then we add on 10, we subtract 20, and we add on 10, and we subtract 20 is too much. Okay, so it's 17.8. Plus 10 minus 20, so 17.8 minus 10 is 7.8. So yeah, 7.8 is how much we have. Well, actually 17.8 from here. There we go. So it closes to a perfect cone, and we'll just double check that by adding on. Oop. Yeah, if we add on a tolerance, we get a flat. Take off the tolerance, we get a perfect point. And then inside of that, oh, but that's not going to give us the same slope. So we actually want this to be 17.8. Okay, and yeah, that's got the right slope. And then we need inside of that. Okay, so for this cone, we actually don't want it poking out the top. We want it only poking slightly out the bottom. Okay, and it's 17.8. There we go. Actually help to do a difference to get a cross section here, but bear with me for a sec. Actually, you know what? Yes, let's do that. There we go. Although I actually wanted it to be on the other side. Okay. Now let's slide it up a little bit. Too far. Let's just make it taller. There we go. Okay, so now we've got our cross section and we can actually see what the hollow section looks like. There we go. We had subtracted too much, and so it had a dimension that went below 0, and it wasn't even basically this cylinder didn't exist at that point, so there was nothing to subtract. But we actually want this to be, it needs to be a little bit shorter. And it needs to be translated down. That looks right. Oh, no, it doesn't quite line up. Wait a minute. I don't want to overshoot it on this one. I actually want it to be the exact same dimensions, just slid down a tiny bit. I think if I take this and this off. That actually made it worse. But now maybe if I shift it down further, let's just do, instead of the layer height, let's do a wall height. There we go. Perfect. This should probably actually work in Vos mode, even. Okay, so let's get this show on the road here. So we want to turn off the difference, the union, the candle, because we don't really care about, we don't want that to render. And there we go. So that's what it looks like. So it will be a hollow cylinder that inserts down into the candle. And then it'll flare out here, and then close off a bit, and flare out again, and then close off. And that should catch some of the candle light, and at the very least I should see it glow. And if that works, then we'll do another version that actually looks a little bit better and more like a Christmas tree. But I think this keeps it fairly low filament for the first version, just to make sure that I've got my dimensions right. And now this is the time where I would crank up the facet number. Beautiful, perfectly smooth cylinders. I mean, if you zoom in close enough, you will still see the facets, but I mean, the 3D printer is not gonna. It's that. This is so fine that you're not gonna see that on the print itself. So let's render. Where's my console here? Console. Now, while that's going, I should probably mention that the colors that you apply to the cylinders and the objects don't actually matter in terms of the finished product. It will still render. The STL doesn't actually have color, at least as far as I know. You could probably use this for doing multicolor, but right now all it does is it just renders a solid object. So the reason that you apply colors in OpenSCAD is so that you can see what you're dealing with. So if I'm printing a mount for a circuit board, I might model the circuit board itself in bright green, and I might do the rest of the design in red or yellow or blue or whatever color I feel like. Usually just the default color, to be honest. I'll use yellow for the actual model that I'm building, and whatever color most closely represents the thing that I'm designing for. So in this case, the candle is kind of a yellowish, greenish white. Oh, we're almost done here. Now is a good time to take a sip of coffee. Just about. Yeah, so another thing that I'd probably want to do is refactor this, because it's currently just got a bunch of different objects that don't really, like this is how I'd write it out the first time when I'm figuring out the alignments of everything, but then I'd usually go back and revise this several times possibly, or depending on how much I care about this object, this might just be good enough for a prototype, and I might move on to a completely different way of doing this. Okay, so let's save this. We'll switch over to the slicer. Saved here. Yeah. And where's my slicer? There it is. Come here, Krita. Come here. Come on, bring it up. is not bringing it up? I want to copy the file anywhere. I want to drop it into. Okay. Here we go. Okay, so that is the object as represented in Prusa. And now let's just check the settings here. I shouldn't actually need any infill. It's only a wall thick. And let's also set... Yeah, let's set spiral vase for this, because this is a prime candidate for spiralization. So it is one parameter, or one perimeter. No top solid layers. Yes, that should all be good. Okay. Now we slice it. And this will take an hour to print and use 5 grams of filament. And because we've enabled the spiralize mode, what it'll do is it'll start on the bottom layer and it'll just print all in one long smooth layer. So it'll the advantage of doing that with something like this is that this is designed to be a light diffractor, right? It's supposed to go onto an LED candle and light up like a Christmas tree. At least the green part of the Christmas tree, which, yeah, anyway. So part of what we want to do there is we want to minimize seams in the object. And so normally when you 3D print something, there will be a spot where every time it finishes a layer, it stops at that same point, and it advances the Z screw. So it goes up one layer, and then it continues. And usually, by default, I think those are aligned, and so you'll see a seam because they all line up, so they form a little bit of a seam on one side of the object. But there are various different settings. You can also enable that it'll randomize the location and stuff, so it kind of hides it. But in this case, if we just turn on spiralize, then slash vase mode, it prints as one consistent extrusion, and there is no seam. There's no point where one layer ends and has to advance the next layer. It is just, it makes tiny adjustments throughout the layer so that by the time it gets back around to the same point, it's already on the next layer. So let's export that. And this one. Save that file, and now let's go over to the printer. Oh, I need to upload the file first. One sec. Because I found that didn't work through the OBS browser. I actually have to do it through a browser. So we'll just upload that real quick. And it should go in the folder. Move into there. Now interact with the browser in OBS. There we go. Let's go down here and start. Okay, so it's heating up the hotbed and the hot end. Okay. And I just did a quick visual check to make sure that there actually is nothing on the print bed before it gets too far into this. Okay, so the nozzle is almost done preheating. And I think the bed goes to 60, so it'll still be going for a little while. There's the print bed on the camera. Oh, right. So now, unfortunately, we probably won't be able to see this one on the camera. So I can't do like a time lapse or anything because the screws that I had, like the T-slot screws that I had used to affix the camera mount, they weren't quite tight enough. So they came because when I designed it the first time, it didn't have any kind of grooves that would hold the T-slot screw in place. So I had to use, I think it was like an Allen key or something to kind of rotate the T-slot and then just gently tighten it into place. So that must have eventually wiggled loose and the camera slid down. So the next version of the camera mount, I will actually be redesigning so that it'll have some kind of horizontal grooves that lock the T-slot into place, so that when you tighten it, it doesn't lose its alignment and it's just locking in. So yeah, I'm going to be redesigning that. But for now, all we really care about is just getting the print started, and then I think we'll cut it there. Because I want to say, I'm pretty sure this has been going on for about an hour. Oh, the other thing we can do, even though we can't see the camera, we can also turn on the G-code viewer. And that will show us what the nozzle is doing, it'll show us the visualization of the G-code that is being currently executed. So right now we will see it do a circle because it's drawing the skirt. But then when it actually gets into the print itself, we won't see any consistent lines because it'll constantly be advancing the layers. So it should do one layer, and then there we go. Wait a sec. It's not what it did before. I'm gonna have to double check and see if it actually is printing in VOS mode or what. Let's look at it in the browser. Because the last time I used VOS mode, oh yeah, there we go. When I look at it in the browser, I see that the layer number is going up very, very quickly. So it's actually at layer 300 now. Oh, okay. Yeah, it's doing it here too. So I guess... Oh, right. There is a setting that tells it to actually print the first few layers in the normal, like... I'm not sure what the conventional way, where it prints it as a layer and then advances and prints the layer and then advances. That must have gotten reset, so it actually probably printed the first few layers with a seam and then went into VOS mode. Here, let's take a quick look at the settings and see if I can spot that. This button. Okay. Yeah. I think it's this one. Probably because it has solid layers set to 4 on the bottom, so it probably goes ahead and does those layers as it normally would. Because you can print there was a Christmas tree I found on Thingiverse that I'd printed for my kids, where it's hollow. You print it in vase mode, but by default it'll close off the bottom with a few solid layers of plastic. So, I mean, it's not going to matter in this case because, okay, so the bottom 4 layers have a seam. Because the way that I designed this object, the bottom was hollow anyway, so we don't have a problem. But that is worth keeping in mind, is that by default, vase mode doesn't automatically hollow the bottom layers. So in future, I'll have to remember to set that to 0, and then it'll actually start the vase, like the spiralization right from the bottom. But that is also useful in some cases, like if you wanted to print a solid base layer that closes off the object and then print a spiral hollow vase on top of it. Okay, so I guess here, let's let that keep doing its thing. Yeah, there's not really going to be much to see on there for a while. And it's going to be running for about an hour, so... Yeah, let's play around with the Stream Deck and see what kind of... I've set up a bunch of scenes here, so let's try this. Oh, they went to sleep. There we go. There we go. Alright, wait, tutorial. Did I restart this? There we go. Okay. Let's that so small? Fit to screen. There we go. That's better. Okay, yeah, let's try this one. Where's the fire extinguisher? Oh, there isn't one. Okay. Oops. This is usually dishes. Start on salad. Sort it. Yes, take the plate. Oh no. We are in peril. Dirty dishes. They must be washed. I can serve one more salad. Let's see. Oh no! We've crashed in through the roof of a sushi restaurant. But the restaurant goes on. Let's get started on... Actually, let's finish off the orders. Okay, so we need lettuce. Lots of lettuce. Dishes. Actually, you know what? Yeah, let's just serve that one. Oops. No. Come back here. Those tomatoes. Somebody's getting impatient. I mean, to be fair, they've been waiting for those salads since the balloon crash. No. Yay! Okay. And yeah, just forget the sushi. Sweet, I passed. Oh, okay, now we gotta go back and see Mr. Onion.
Well, my word, what an adventure you've been on, and you've only just begun. You still have much to learn about cooperation, and we can only keep the unbred at bay for so long. Head out into the wild country. I hear there are flavors there that can satiate even the most ravenous appetite. Bark! Don't hurry me. But he's right, you must go now, and bring back more delicious teamwork. Bark! There's no time to lose. There's no time for chatter. Go now.
Oh, we can give Kevin scritches.
Good boy, Kevin. Okay. Let us go on our way.
Awesome. So we have a new chapter. But I think that's where we'll park that for now. Let's just switch over here to... Oh. There we go, the other screen. Okay, let's just draw something quick. Okay, so today what we designed was, instead of something that actually looked like a Christmas tree, we just did something like a... Oh, hang on. Let's at least set it to green. Where'd it go? So we went up, and then 45 degrees, 45, 45, 45, closed it off. Yeah, I'm sure I probably got some of the angles wrong, but whatever. It's just meant to be an approximation. And yeah, let's have a little bit of fun with this before we end the stream. I actually like how that has kind of a light touch to it, although wait, it looks like it's hollow. Here, changing it more like... Oh, because it might be smearing the white. Yeah, let's try... There we go. Yeah, if I make it too fine, then it actually is hollow because it's smearing the white as I... here, let's change that to dulling. There. Although sometimes, like if you want that paint effect, you do actually want the smearing. But right now, because it's all just white canvas, all that's going to do is just pull the white along with it. I have to remember to reconfigure this to add on some more tools, because there was a whole bunch of really cool tools when I was looking through it the other day. But they don't all show up in here. A bunch of them are kind of hidden off in the tray in Krita. So I'm gonna have to spend some time configuring my, I don't know, I guess it's kind of a palette, but it's more of like a tool palette. Yeah, that doesn't drag it with it as much. It just kind of fades in and out. And I can also tune down the opacity too. Make it more like a watercolor. Oh, that's too transparent. Let's try that. Still too transparent, doesn't really show up well on the tree. Let's use some thicker paint. There we go. Actually kind of hard to write with this. Here, let's try that again. Let's still use the fountain pen. Okay, so it's not too bad. I still have to probably need a little bit more practice with this. And maybe it would help if I used... Yeah, let's try a pencil. Let's try... There we go. Yeah, that actually... I don't know. I mean... Let's try writing a little bit finer. Okay, yeah, it's not too bad. And then, I don't know, let's try blurring it with some... Controls go. No. Wait. Yes, those are the controls. Why are they not? Weird. Okay. so let's make it some watery paint. And wait, where's my... down a bit with there. Let's try a different color. Like let's trace over this one because this is the biggest one. So it's gonna like, oh, so I don't even have to do it fast. I can just go nice and slow and that it only colors on the outside of the brush, which is kind of interesting. What else can we do with this? So that looks like it's a mark. Oh, it's a very watery marker. That's because, oh no, opacity's up all the way. Okay, let's go with something else. And what should we do with the pen? Let's draw some trees. That was the wrong tool for that. That's a solid. No, that's too thick. A smaller marker. Better. And now, yeah, let's keep the marker, and I think let's put a red Christmas ball on top of our little Charlie Brown tree there. Let's lighten up this water a bit. That actually kind of creates a nice effect, blending the colors. Just lots of little brush strokes in various opacities. I'll figure out this art thing yet. I think one thing I should do for next time is actually set up the palette, because I think in episode 1 1 of Bob Ross, which is what I was planning on doing, some Bob Ross like paint along types of things. In episode 1, he gives a palette of all the colors that he's going to use in season 1, and possibly seasons beyond that. I don't know if he changes the palette at all. But that is one of the things I'll configure on here for next time, is get the Bob Ross colors going here, so I can actually try doing some paintings. Well, that's cool. It's got some texture to it. Needs to be a little bit less. There we go. Nope, still. Maybe too big as well. Let's try that. Just want some little. Oh, I just want little yellow flowers, not... Am I using the wrong brush? Let's try this one. Yeah, because this one will do the smearing. In fact, I actually really want that to be a little bit less transparent than that. A little bit more opaque. Let's brighten the flowers a bit. And let's throw in some little purple flowers at the bottom. Just little tiny ones. I'm not really sure where else to go with this for now, so I think I'm just gonna, yeah, we'll just call it quits there for today. Okay, so let's go back over to OBS and actually let's take one last look and see how the print is coming along. Yeah, it's only about halfway, so we'll let that keep doing its thing. It'll just keep chugging along. And that's it. We're gonna park it there for today. Kind of went way longer than I intended to, so yeah, I don't know. I've been putting it off for a while, so I wanted to try doing a few things, get some things printing, and play around at the Wake Home tablet a little bit more. So yeah, we'll leave it there. Have a good day, and I'll try to start posting more regularly now. There's a bunch of projects that I want to start working on in the new year, and now that the holidays are over, yeah, I think trying to do Advent of Code every day was a little bit ambitious. I got kind of tired of that pretty quick. Not so much about the coding, just, I don't know, coding on a daily schedule during your holidays while you're trying to spend time with your family is a little bit not really what I wanted to do in December. So sorry about that. But we'll try posting more in January. So have a good day, and see you all tomorrow.